Well, hello again, everyone. Mr. Reeves back with you today. And today we are looking at reflections of polygons over lines. So we're continuing our study of geometric transformations, specifically looking at reflections. All right, so in a previous video, we looked at reflections of polygons over just the x and the y-axis. Today we're going to expand that to looking at reflections of polygons over a vertical line, a horizontal line, over the line y equals x, and over the line y equals the opposite of x. But we are going to just go ahead and start by reviewing what we had learned previously. So if you take a look here on the coordinate plane, just a quick reminder of some vocabulary. We have this polygon here, which happens to be a triangle just for simplicity. This is called our pre-image. So the polygon, before you do any transformation, in this case reflection, is the pre-image. Right here we have a line. This line right here is going to be our line of reflection. And after reflecting, we're going to get a triangle over here, and that is going to be called our image. So we're going to take our pre-image, reflect it over the line, and we're going to get an image, and then we're going to try to make sure that we can do that for any polygon over the y-axis. All right, so I'm going to go ahead and go to my menu here and tell my handy-dandy Inspire that I would like to do a reflection. And I'm going to choose my triangle. And I'm going to choose this line, again the y-axis, as my line of reflection. All right, and then let's go ahead and add those coordinates in right here so we can see clearly what our result was. All righty, there we go. So let's just line these up a little bit better here. All right, and as you can see, we got an image over here of our pre-image. And one of the great things about this software is I can move it all around now, and you can see what that reflection looks like. All right, so let's take a look at these coordinates and see what we notice. Well, the triangles are directly across from each other, right? So when I move this one up, that moves down, which means that the y values are the same. So if you take a look at all those coordinates, you will notice that the y values are the same. What about the x values? The x values are not the same, but they have the same absolute value because they're opposites. So that's 4, that's -4, that one's -4. Combined over here with a 4, and the -7 corresponds to the +7. That's because they're the same distance away from the line of reflection. Remember, absolute value is the distance away of a point, on the number line from 0. So these are each 4 away. These points are 7 away. One's to the right, so it's positive. One's to the left, so it's negative. So anytime you reflect over the y-axis, you're going to get this result. Again, the y values will be the same, and the x values will be the opposite. So let's go ahead. If you haven't already written that rule down, it's a very good thing for you to do, to write these down and to take notes of them, and then of course memorizing them would be even better. All right, so what we have here is a reflection, right? And you can reflect over any line. This is a reflection across the y-axis. And when you reflect over the y-axis, this is how we write our rule here. We say for any ordered pair xy, again, this right here is our pre-image, right? This is our pre-image. And this over here is our image, right? Any point xy gets reflected to, what did we say about the x's? They become the opposite, -7 to 7, -4 to 4, -4 to +4. And what about those y values? They stayed the same. So reflection over the y-axis, here is our rule. Okay? All right. So let's take a look then next at a reflection over the x-axis. All right, so here we go. So again, I'm going to go to my menu and tell the Inspire that I would like to do a reflection. And again, we're reflecting the triangle, only this time we're reflecting over the x-axis. All right, and once again, we're going to go ahead and pull up those coordinates. So I'm going to get that one there, that one there, that one right there. That's as far as it's going to let me pull it over here. All right, let's see if we can get it over a little more. Okay, so as you can see, we get a little bit of a different result. If we had reflected over the y-axis, we'd be over here, right? But we reflected over the x-axis, so we're down here. And once again, I can move my original around, and you can see that as I travel right and travel left, the image follows the pre-image. Again, I can go up and down and overlap, and you will see now, instead of lining up horizontally like they did for the reflection over the y-axis, they line up vertically, right? So when we compare these coordinates, take a look at what's the same and take a look at what's different. Well, what do you see that's the same? -4, -4, -4, -4, -6, -6. This time it's not the y values that are the same, it's the x values that are the same. And take a look at those y values. 1 and -1, 7 and -7, right? 3 and -3. So what happened? The x values now are the same and the y values now are the opposite. All right, the x values are the same because as I move to the right or move to the left, they completely line up, but the y values are the opposite. What is up is down and what is down is up, right? So if we're going to go ahead and write a rule for this one, let's go ahead and get our pen out and write a rule for this one. Here we go. So what do we have here? So our rule, this is going to be our rule for a reflection. What is this reflection? This is a reflection across the x-axis. And when we reflect over the x-axis, again, we have our xy. Again, this right here is our pre-image. And this one down here is our image. And any point on the pre-image, when I reflect it down to the image, again, what happens? The x values are the same, right? And now it's the y values that are the opposite, right? The x values are the same and the y values are the opposite. That's what happens when you reflect over the x-axis. All right. Okay. So those two were covered in a previous video, but if you didn't watch the previous video, guess what? You know it now. All right. So let's go on now to any vertical line. Now, real quickly, let's clarify. If I move that line right there, that vertical line is the y-axis, and then it would work exactly like it did up here when we reflected over the y-axis, right? Okay, except now what are we saying? Now I'm saying I can move this vertical line anywhere. I'm not going to just limit myself to the y-axis anymore. I'm going to go anywhere here. All right, so I'm going to go ahead and put it right there at x equals -2. And we're going to do a reflection of our polygon, our triangle. We're going to take our pre-image. We're going to reflect it over this line, which happens to be x equals -2. And we're going to see what happens. All right, so here we go. Back to my menu, transformation, back to reflection. Reflect the triangle over the line, and then I'm going to go ahead as I have been doing and getting these coordinates and placing them conveniently so we can make a comparison. All right, so let's take a look now at what we have going on here. All right, so remember before we were looking at things that were the same and things that were different and trying to see how they are related. Well, let's take a look as we move this. Does this look familiar to you? As I move it up and down, right, it's directly across from each other. Does that remind you of when we reflected over the y-axis? All right, that's because the y-axis is a vertical line and this is a vertical line. And when you reflect over any vertical line, right, it just goes directly across. Those y values are the same. Now, hopefully you remember when we reflected over the when reflected over the y-axis, the y values were the same, but the x values were the opposite, right? Well, take a look on here. The x values aren't the opposite anymore. That's -6 and that's 2. That's negative and that's something crazy over there. I don't know what's going on, right? So as I'm not seeing an obvious relationship here. And by the way, I can move this line however I want to. When I move it back there, they're opposites, right? But as I move it closer, notice those x values are changing. So how can we actually see what those x values are supposed to be? Well, let's take a closer look. When we look at this reflection, let's go back up to the y-axis. So y, right here, the x values are the opposite because they were the same distance away. Remember we said they have the same absolute value because they're the same distance away. Well, if we take a look here, they're still the same distance away, right? If I were to measure from there to there, 1, 2, 3 units to get to that red line. 1, 2, 3 units to get to that red line, right? So if I look at this one right here from that point right there, 1, 2, 3, 4, 5, 6, 7. And if I go over 1, 2, 3, 4, 5, 6, 7, I'm there. So maybe it would be helpful if I went ahead and drew in a line segment. So I'm going to go from there to there. See how those are straight across from each other, right? And from there to there, and from there to there. That looks kind of cool, doesn't it? All right. Now I want you to watch. As I move this triangle, right? Can you see how those line segments, they're the same distance. Those points are always across from each other. And this line of reflection is always exactly in the middle of those two. Do you see that? Do you see that? Okay, so when we go to make a rule for any vertical line, it's going to be a little bit more challenging than over the y-axis and the x-axis, which is why we always do those first. All right, so let's go ahead and see what we can come up with as far as a rule. Wow, crazy stuff going on here. All right, as far as a rule for what we can do for when reflecting over a vertical line. All right, so here we go. So for a rule over reflection across a vertical line, all right, so it's going to look a little bit differently. We're going to have our x and we're going to have our y. Now one of these is going to be easy. Remember the y values stayed the same. So I'm going to just put that right there, okay? The y values are staying the same, right? But the x is a little tricky. So rather than putting it as a symbol, I'm going to put it in words. All right, so it's going to be the same distance away, but on the opposite side of the line of reflection. Wow, that really is not great to see, is it? All right, how about if I write it like that? Okay, so for any ordered pair, again, this over here is our pre-image, and this one here is our image. For any ordered pair, the x values are going to be the same distance away, but on the opposite side of the line. So if I have this point right here to get to the line, it's 1, 2, 3, 4, 5 units, right? And then to get over here, 1, 2, 3, 4, 5 units. The same distance away, right? 1, 2, 3 units. Right here, 1, 2, 3 units away. So the same distance away, but on the opposite side of the line of reflection, and then the y value stays the same. All right, so again, I hope you understand that's not necessarily the best way to write it, but I think for where we're at, that's just the best way to describe it. There actually is an algebraic rule that you can describe in terms of the line, but it's just more confusing at this point than what it's worth, okay? So we want to be the same distance away, so just start with your point, work to the line, find that distance, and then do the same distance across. All righty? Okay, so that is a reflection across any vertical line. All right, and you're going to see things are very similar with a horizontal line. Again, if I move the horizontal line right there, that is our x-axis. So things are going to be somewhat similar to reflecting over the x-axis. So let's go back to geometry. Let's go to our transformation. Let's do a reflection of our triangle over our line right here. And as we've done, we will continue to get these coordinates so that we can make some comparisons here. All right, so let's take a look at what's going on. Again, let's just take a look in general. You could see as I move left, it goes left. As I move right, it goes right. When I go up, that other one goes down. When I go down, the other one goes up, right? Interesting, interesting. And again, I can move this line however I want to. All right, and you'll see no matter how I move this line, they're lining up vertically, right? They're lining up vertically. And then these distances are the same. Okay, so since they are lined up vertically, what do you notice? -7, -7, -6, -6, -5, -5. So just like when we reflected over the x-axis, the x values are the same. Remember that? The x values are the same. That's going to happen with any horizontal line. The x values are going to stay the same because no matter how I move that line, it doesn't shift left or right, right? They will always line up vertically. Now, what about those y values? Now, again, when I have my actual x-axis, those y values are the opposite. But the reason they're the opposite is because they're the same distance away from the line. So if I move the line, they're still the same distance away. They're still the same distance away from that line, but the y values are going to look different, right? I wish I could somehow get this to be a little more clear. I don't have a lot of space here. All right, how about if I make my triangle a little shorter? Can I do that? And then we could fit more in there. All right, so then I can have a little more space there. Let's even do one more down. How about that? And then I can move this down to here. All right, get this a little more clear. So again, the x values are the same, but take a look at the y values. So I'm going to do what I did before. I'm going to go ahead and put those lines in. So we can see, whoops, we want to go to geometry and we're going to put in some line segments. So if I go from there to there, those points line up. If I go from there to there, those points line up. And if I go from there to there, those points line up, right? And my line of reflection is exactly in the middle, right? It's exactly in the middle. So again, as I move around, you see how they perfectly line up. And that purple line is always in the middle. So if we mark off distances right now, for example, from there to there, it's 3 units, right? 1, 2, 3. From there to there, it's 3 units. That is also 3 units. If I go from there to there, 1, 1, 2, 3, 4, 5, 6 up, 6 up from the line. And that one is 1, 2, 3, 4, 5, 6 down. So this one is 6 units. All right, so if we're going to write the rule, if we write it the same way that we did for the last one, let's take a look at what we get. So this is a rule. And this rule, let me try that again. This rule is for a reflection across any horizontal line. And when you reflect across a horizontal line, again, this is our pre-image. This is our image. Let's take a look at what happens. All right, the x values stay the same, right? So when I do my reflection, the x values stay the same, but what happens with the y values? All right, so the y values are the same distance away, right? Same distance away, but on opposite sides of the line of reflection. So if we were to take a look back at what we had before, same distance away on opposite line of reflection, does that sound familiar? When we reflected over the vertical line, that's what happened with the x's, and the y's stay the same. When we reflect over a horizontal line, the x's stay the same, and the y's are the same distance away, but on opposite sides, right? So again, if I make all this go away, if I move this point, do you see? I'm moving it closer to the line and the other one is moving closer. 1 away, 2 away, 3 away, 4 away, 5 away. See how that works? The y values will always be the same distance away and the x values are the same. If I go over here back to my vertical line again, as I move that point closer, 1 away, 2 away, 3 away, 4 away, 5 away. See how that works? They're the same distance away, but on opposite sides of the line of reflection. And honestly, that's how it always works for any point over your line of reflection. It will always be the same distance away from your line of reflection, right? As I move that one closer, the other one moves closer. See how that works? Pretty cool. Pretty cool. All right, 2 left. 2 left. Here we go. We now have the line y equals x. The good news about the line y equals x and y equals the opposite x, we're back to easier rules to write. So you'll see that pretty quickly here. Just like for reflecting over the x-axis and the y-axis, we'll have a nice, clean, easy rule to write. So here we go. All right, back to, you guys are all experts at this, geometry, transformation. I'm going to do a reflection of my pre-image over my line right here. Oh, wow, interesting. Going to go back. I'm going to get my coordinates. Here's that one. Here's that one. Here is that one. All right, pretty cool, actually, I think so, man. All right, so I'm going to go ahead and move things a little bit closer here so we can see, and maybe move these down a little bit. So let's compare these coordinates. All right, so actually let me do something else real quick. I'm going to go ahead, I'm going to go ahead and draw on those lines that I drew in before just to emphasize what's going on here. So let's do some segments, right? So do you see how that point goes to that point, right? And that point goes to that point, and that point goes to that point. Kind of looks like a triangular prism now, doesn't it? Alrighty. Okay, so when we take a look at that reflection and we match up those points, let's see what's happening. First of all, even before we do that, if we take a look at these distances, again, the distance from the point to the line is the same. So if I move this point here, see how those are getting closer to the line and then back further away? Or if I move that one closer to the line and then back further away, if I can get this point closer to the line and then back further away. All right, is that how I had it? I think that's how I had it. Doesn't really matter. Okay, so let's compare these coordinates, knowing that the distance of each point from the line is the same on either side. Take a look. So for this point right here, the x value is -4. For here, the x value is 6. But wait, I'm looking at these points and I see a 6 and a -4 on both of them. They're just switched, huh? Did that work for this one? A -4 and a 1? And a 1 and a -4, and a -6 and a 1 and a 1 and a -6. Oh my goodness, can it really be that easy? And the answer is yes, it can be that easy. When you reflect over the line, y equals x. Let's see the rule that we get. So we have the rule, and this is for a reflection across the line y equals x. So this is our line, y equals x. That blue line right there is the line y equals x. When we reflect across that, what happened? Our x became our y, and our y became our x. So what would I do here? xy would become, that's right, y x. It's that simple. It really is that simple. And we could go into a lot of details as to why that happens, but at this point I don't really expect you to know why, just that it does, and that's how you reflect across the line y equals x. All right, and finally here, I know this has been a long video, we're almost done, I promise. Now we're going to reflect across this line, which is y equals the opposite of x. You notice that one goes up from left to right at a positive slope of 1, or a 45-degree angle. This one, right, goes down from left to right. It has a slope of -1, goes down at a 45-degree angle. All right, and for the very last time, we're going to go to transformation. We're going to go to reflection. We're going to reflect our preimage across our line, and there it is. All right, and I'm going to go ahead and let's see here. I'm going to pull this in a little closer over here, maybe make it a little bit smaller so we can see a little better. Gosh, I love Inspire software. It's so easy to work with. All right, and then I'm going to go here to coordinates and equations and put the points there. All righty. And again, let's draw the lines connecting. Whoops, I always do that. I'm going to draw it, but we're going to use the Inspire to draw it, not my Mobi. So let's go ahead and make a segment. Let's see. I think, does that one connects to that one, right? Do you agree those 2 points are the same distance? They're reflected across that line, right? And this one goes to this one. Yeah? And then this one goes all the way over to that one. Again, any two of these points are the same distance away from that line of reflection, right? Do you see how that? They're the same distance away. I'm getting closer and closer to that line of reflection, and further apart. Those distances are always going to be the same. All right, so last time, what happened here? Again, when we reflected over the line y equals x, the x and the y just switched, right? Again, we ended up with that rule right there. X to y, x comma y, excuse me, goes to y comma x. Does that work this time? Well, if we take a look at these corresponding points, wow, -3 became +3, +3. From that one, it looks like they just become the opposite. That would be really cool, right? But if you take a look at this one, -7, -4, did it become +7, +4? No, there's a +7, but it's in the wrong place, right? So this 3 isn't really a great point to look at. So let me switch that, and now we'll make it a little more clear. So we are getting opposite signs, right? But not only are we getting opposite signs, once again, the x and the y values are reversed, right? So here I have -2, 5. Here I have -5, 2. So the x and the y switch, and they become the opposite, right? -7, -4 became +4, +7. And -3, -2 became +2, +3. All right, so let's go ahead and see if we can get this rule down, and then we are done, and you're going to be ready to do some practice. Isn't this exciting? So this is a rule. This is a reflection across the line. I haven't been putting the line, have I? A reflection across y equals the opposite of x. Interesting, it's the opposite of x. And what do we get? Again, this over here is our pre-image, right? And this one here is our image. And I haven't said it, by the way, but honestly, we could go the other way too, right? If we had started over here, this could be our pre-image, and that would be our image. It works the same both ways here. All right, so here we go. What is our rule? We have x comma y, and what did we say happens? They switch, right? 3, 2, 2, 3, 7, 4, 4, 7, 5, 2, 2, 5. So they switch, but they don't just switch. They become what? They become the opposite. Let me give myself a little more room here. They switch and they become the opposite. Now, real quick, that does not mean -x, and that does not mean -y. Take a look at these. They're both positive, right? But they're the opposite of what these? The opposite of -3 is a +3. The opposite of +2 is -2. So don't read this as -y. I'm not saying the answer is going to be negative when you start with, well, it will be actually. When you start with positive, they'll be negative. But sometimes you're going to start with negative, and then it becomes positive. So when you reflect over the line y equals the opposite of x, you switch them. xy becomes yx, but then you have to make them opposite. So the actual rule is any ordered pair on the pre-image, xy, becomes the opposite of y and the opposite of x. All right, so I sure hope that was helpful for you. We started off with the y-axis, and on the y-axis we said that the y values are the same and the x values are the opposite. Then we went to the x-axis, and for the x-axis, those x values are the same, but the y values are the opposite. Then we said we're going to look at any vertical line, and for any vertical line, those y values are the same, and the x points, these x values, you just have to say are the same distance away from that line of reflection. And for any horizontal line, now it's those x values that are the same and the y values that are the same distance away from that line of reflection, right? Over the line y equals x, we just switch the order. The x becomes the y becomes the x. And finally, over the line y equals negative x, we switch the order and we make both of them their opposite. All right, guys, I hope this was helpful for you. I know it was a long video, but we covered a lot of things, and hopefully you're able now to do these type of problems when you're asked to reflect over these types of lines. Have a great day, everybody. Thanks for watching.